video I'm going to look at the 2012 question 3b Leaving Cert Applied Maths. So we have a particle which is projected down an inclined plane with an initial velocity of 20 meters per second. That 20 meters per second is at a right angle to the plane. The plane of projection is vertical and contains a line of greatest slope. The particle strikes the plane at Q. The range of the particle on the inclined plane is 1600 root 3 over g. Find the value of A and then find the magnitude or the rebound velocity at Q if the coefficient of restitution is a half. So first thing you always do with this, or I always do, is I always resolve my G. So what we do is we look at this question in two parts. We look at it along the plane, which we call our x direction, and we look at it perpendicular to the plane, which we call our y direction. And I could actually put my x that way because I'll make that the positive. So we need to resolve all our kind of speeds in these two directions. So g acts straight down, so we want to resolve that into a component which is perpendicular to the plane, which would be g cos alpha, and a component horizontal to the plane, g sine alpha. So now let's look at our initial velocities. So our initial velocity in the y direction is going to be 20. Our initial velocity in the x direction is going to be 0. Because our x direction is parallel to the plane and it has no velocity in that direction initially. Our equations then, we're going to use s equals ut plus a half at squared. So what I like to do is I like to write out my equations in the x and y direction first. So sx will be u in the x direction, which is 0, times t, plus a half a. Now in the x direction the acceleration is g sine alpha, and that's working in the same direction that the ball is travelling. So that is going to be plus a half g sine alpha times t squared. Our sy equation then will be our initial velocity u, which is 20, times t, minus a half g cos alpha t squared. And it's a minus because it's going to slow down the projectile in the y direction. Let's do our velocity equations then. So we v equals ut plus a half at squared. So vx will be 0 plus g sine alpha times t, and vy then will be 20 minus g cos alpha times t. So that's what I do first. I just write down all the equations I'm going to use. Now 9 times out of 10 with these questions, the first equation you use is the sy equation, because when the projectile strikes the plane, sy is going to be equal to 0. So we can put our sy equation, which is this one, equal to 0. So that gives us 20t minus a half g cos alpha t squared equal to 0. And if you rearrange that, you get an expression for t, which is t is 40 over g cos alpha. I won't do this bit because I reckon you're going to be okay with that bit. No. So that's actually worth 5 marks and 5 marks. That's 10 marks got already. Now we have an expression for the time taken for the projectile to get from here to here, for it to land. So what else do we know about this point? Well, we know the range, in other words the x direction distance it has travelled, is 1600 root 3 over g. So we're going to use this equation now, and we can put that equal to 1600 root 3 over g at the time taken for the full trip. So that becomes, our sx equation is 0t, so we don't have to write that, a half g sine alpha t squared. And we know when t equals this, when that's a half g sine 40 over g cos alpha squared, the range, or the distance it has travelled, is equal to 1600 root 3 over g. So now we want to simplify this down, or we want to work this out. So we're going to get a half g sine, sorry, that should be alpha, so that's g sine alpha over 2 multiplied by 40 over g cos alpha squared, which would be 1600 over g squared cos squared alpha, equals 1600 root 3 over G. That G will cancel with one of those. That G will cancel with that. That will cancel with that. And we end up with sine alpha over 2 equals, over 2 cos squared alpha equals root 3. Or if you want, sine alpha equals 2 root 3 cos squared alpha. Now we have an equation here, but the question was to find alpha. And we can't find alpha when we have sine and cos. We need to have all sines or all cos's. So we're going to have to go to our formula and tables book and pick a formula that we can use to change something. So the one I'm going to use is I'm going to use the fact that cos squared alpha is equal to 1 minus sine squared alpha. And that will give me all sines in this equation. So this equation will become sine alpha equals 2 root 3 1 minus sine squared alpha. So when you multiply all that out, you should end up with this equation, 2 root 3 sine squared alpha plus sine alpha minus 2 root 3 equals 0. Now when you look at that equation, hopefully something jumps out at you. And what should jump out at you, that this is very similar to a quadratic equation, or not similar, this is a quadratic equation, where our x could be equal to sine alpha. So you could rewrite this as 2 root 3 x squared plus x minus 2 root 3 equals 0. So if we solve that quadratic equation using our minus b formula, and our minus b formula being minus b plus or minus square root b squared minus 4ac all over 2a, we will get 2 solutions for x, but that's 2 solutions for sine alpha. Now just to save time, I'm not going to do it fully, but one of the solutions for x you should get is you should end up with, well, what you should end up with at the end is x equals sine alpha, which equals minus 1 plus or minus 7 over 4 root 3. So that's what you should end up with. Now, one of those answers will give you a negative number, which we don't use, but the answer which gives you a positive number will be minus 1 plus 7, which is 6 over 4 root 3, which is the same as 3 over 2 root 3. So you can type that into your calculator to get a value for alpha, or what you might spot is this looks very similar to one of our kind of common angles, in which we can rearrange this to give us root 3 over 2. So sine alpha equals root 3 over 2, therefore alpha equals 60 degrees. So that's your answer for the first part. And I think you have 20 out of the 30 marks got for that, or 25 out of the 35, whatever it is. So alpha equals 60 degrees. So the magnitude of the rebound velocity at Q has a coefficient of restitution of a half. Sorry, the magnitude of the rebound velocity at Q if the coefficient is a half. So what happens is we have the particle bouncing here and coming up again. But remember, when we're dealing with these, this is kind of from question 5 really, isn't it? But when we're dealing with things landing at an angle, what we usually do is we usually redraw this picture so that the particle, or that the plane is horizontal and then the particle is going up like this. So the particle is going to land here. And when it lands, it's going to have 2 components. It's going to have the vertical component, which will be its final y velocity. And it's going to have the horizontal component, which will be its final x velocity. Then it's going to rebound up. Now from chapter 5, we know that that x velocity will remain the same, but this y velocity will change. So I could really call this u, but this y velocity will change. And if the coefficient of restitution is a half, it's going to be a half what Vy was. So this will be a half of what Vy was, because it loses half of its energy. So what we need to do is we need to figure out Vy and Vx. So Vy is 20 minus g cos 60 times t. Now t, remember, we had an equation for it, was 40 over g cos 60, because alpha is equal to 60. So well, that will cancel, that will cancel, they'll cancel. We have minus 20. So this velocity is minus 20. That means the rebound velocity is going to be plus 10. Let's find Vx. Vx is going to be equal to 0 plus g sine 60 times 40 over g cos 60. So you can do a bit of calculator work with this and you should get an answer of 40 root 3. So Vx is equal to 40 root 3. Now the question was the magnitude of that velocity. So we have our x component and our y component, our x component and our y component. So to get the magnitude of that velocity, it will be the square root of 40 root 3 all squared plus 10 all squared. And that works out as 70 meters per second.